Hello and welcome back to Jason Live. My name is Patrick Shea, and we're here once again with our STEM career series, where we learn about careers in science, technology, engineering, and math. Today's STEM role model is Patricia MacQueen. Patricia is a volcanologist and geophysicist. While pursuing her master's degree, she studied active volcanoes in Central America and Hawaii, making precise gravity measurements to better understand their internal structure. Today, she's working with a company that builds gravity sensors like the ones she used in her research. We're going to learn all about that and more in just a moment. But before we do, just want to remind everybody out there that today's event is live and interactive. You can interact with us by using the box just below the video window. You can send us questions and participate in our polls. We'll try to get as many of you involved today as we can. Right now, it's time to get Patricia involved. Welcome, Patricia. Thanks for joining us.
Hello.
Hi. Awesome to have you here. And I know we have a lot of folks watching today who are very, very interested in volcanoes in general, and certainly in the work that you do to study them. So why don't we get started by having you define for us what exactly is a volcanologist? And I said you were a geophysicist as well. Why don't you tell us what a geophysicist does, and tell us about your work and the kinds of things that you do.
So simply put, a volcanologist is someone who studies volcanoes. So the way I study volcanoes is I use geophysics, and geophysics is usually taking, measuring things on the surface, maybe like the motion of the Earth through seismology, or measuring temperature, and then basically throwing a lot of math at these measurements and getting out pictures of what's underneath the Earth without actually having to go there. So what I do as a geophysicist is probably something you've never heard of. I measure very small changes in gravity because, believe it or not, gravity does change from place to place. By very small, you're not going to feel it. But it's the same idea as when you go to the moon, you weigh a lot less. And when you're out in space, you float around. That's because when you're in space, you're very far away from the Earth, from the mass. And when you're on the moon is very small, so it doesn't have a lot of mass. So when you measure very small changes of gravity on the surface, you can get information about what's under the ground, how much mass is under the ground, find where the dense rocks are and find where the fluffy rocks are. So when you do that on a volcano, you can figure out where the dense rocks are, which is usually magma, the solidified lava, or sometimes liquid lava underneath the volcano, and you can tell that apart from the fluffier stuff around it. And if you can tell where the magma is, that can tell you something about how big the eruptions might be, or what kind of activity this volcano might have.
So a couple of times there you mentioned fluffy stuff or fluffy rocks. How can a rock be fluffy?
So volcanic rocks are very good at being fluffy, because the reason that volcanoes erupt is because you have melted rock with lots of bubbles in it. And it's the same, if you've ever done the Diet Coke and Mentos experiment, that is the best volcanology experiment ever, because it's the same thing that happens in volcanoes. You get a lot of bubbles in this lava and it wants to come out, and when it comes out, a lot of these rocks they cool quickly with all these bubbles inside, so the rocks are very fluffy. In fact, if you pumice, this is pumice. Sometimes pumice will float on water. And there's a kind of rock in Hawaii called reticulite that has so many of these bubbles in it that it actually looks like foam, but it's a rock. So that's what I mean by fluffy rocks, because they really are actually fluffy.
So we're going to get into, I'm sure, a lot of that stuff in more detail, especially the gravity measurements that you described. But we're going to start taking some questions from our audience. Our first question today is from Isaac. He wants to know, have you ever been on or at a volcano when it erupted?
Yes, I have, twice actually. So I think Patrick has been showing some footage that I took in Hawaii. I worked in Hawaii for a summer, and the volcano in Hawaii that's active is called Kilauea, and it was erupting at the time, so it was erupting lava flows. So those are non-explosive, but they're really fun because you can go up to them and you can outrun them at a walk, so it's less dangerous than some volcanic activity, although not to be trifled with. And then the other time was I was at a conference in Japan, and this conference happened to be next to the volcano Sakurajima. And this volcano, currently its activity is it's erupting explosively So as you can see in the video, these big plumes of ash and gas. So it's doing that pretty much 2 times a day. So I got to go over there with hordes of other volcanologists who are all so excited to see this volcano and taking pictures and videos and basically having the time of their lives. But it's a smaller explosive eruption, so we could be near to it and not be in too much danger. But it's not something you want to travel with. The volcanoes can be unpredictable. So don't go rushing off to find explosive eruptions.
It's our first piece of great advice for the day. I'm sure there's going to be more, but don't go off looking for explosive eruptions is number one. We're going to move on to our next question from Forrest. He wants to know, how many volcanoes have you worked on, and which one is your favorite? You just mentioned a couple.
I have to.
Oh, we've stumped you.
Well, I have to think about which ones I've worked on. Well, I think so. Okay, I worked on Cerro Negro in Nicaragua. I haven't really worked on Sakurajima. I've been to Kilauea. I've been on Colima. I think my favorite was Kilauea, just because there's so much different at that volcano. You have the lava flows and all the wonderful, amazing shapes those make, and then you also have something that's little known about Kilauea is it can actually also erupt explosively. So that's where you get the reticulite that I mentioned earlier, those really fluffy rocks, and you can also go around and you see lots of deposits of ash. They have occasionally little tiny drops of glassy lava that are called Pele's Tears. But I loved it because there's just so much different and so much to see at Kilauea. So many different aspects of volcanology that you can see in just one place.
And here you are at Kilauea, clearly having a good time on your favorite volcano. We're going to keep on moving here with a couple of related questions from Adam and Emily. Adam wants to know, what's the most dangerous thing you have done in your career? And Emily wants to know, have you ever been injured while working on a volcano? As you might imagine, we got a lot of questions for you about the danger aspect or the injury aspect. Why don't you tell us about that?
Yeah, my mother wasn't entirely happy that I was interested in volcanology. I think actually the most dangerous thing, at least that I felt that I've ever done in volcanology, well, it's probably a tie between one time I was working on Hawaii and we were working around the most recent active cinder cone called Pu'u'o. And that day happened to be, it was very cloudy and we were working in a lot of areas where there was volcanic gas, so I had to wear a gas mask. And it was a little scary because we were walking in terrain that could suddenly collapse beneath our feet, and we knew there were several pits nearby, but we couldn't see very well, so it was a little dicey. And then the other time that scared me pretty bad was I was working in Nicaragua near Cerro Negro, and there was a small forest fire nearby, and one of the sites that I had to go to measure was fairly close to this forest fire, and I could hear it. And I'm from Colorado, so I've grown up with hearing about forest fires, and it's always been something that's kind of worried me in the back of my head. So I think that was the most scared I've ever been in a volcano, was actually not the volcano, was hearing that forest fire nearby and thinking of, oh gosh, what do I do if it gets close? I have to watch this instrument, but I have to leave. Have I ever been injured in a volcano? Actually, not seriously. I tend to injure myself in mundane ways like falling on the sidewalk. I think the worst I've ever gotten in a volcano is I think I bruised up my knees pretty bad tripping, and I kind of banged my knees on some rock, but I haven't actually ever been seriously injured on a volcano, believe it or not.
That's good to hear. We're going to move to our next question from Andre, who asks, what do you like better, field work, working on the volcanoes, or working in the lab? So we really haven't talked about that aspect of your job. Why don't you tell us a little bit about that and answer Andre's question?
Yeah, that's actually a really good one, because the reason a lot of people go into earth sciences is because they love being outdoors and they love doing the field work. And for me, I have to confess, sometimes it's the opposite. I do enjoy the field work sometimes, but for me, what really gets me excited about volcanology is the geophysics that I do in the lab. I've always been fascinated by geophysics because it's a lot of times you get all this data that looks meaningless, and then you can manipulate it with computers and with math, and you can just draw out all this information just by applying science. And that is really what makes me excited, when I can take this data set that looks meaningless and make meaning out of it. And that's really, for me, that's what gets me excited about volcanology and geophysics, is being able to apply the powers of my mind and the computer to be able to see inside the earth without actually ever having to dig anything.
This brings us to a question from, I believe it's Manisha. What are the most important machines or technologies or tools that help you do your job?
So as I've already mentioned, one very important part is the computer. And I use a computing programming language, I'm actually not sure the correct term, called MATLAB, which is, so I do some coding and some programming on my own, and that's very important. And then for the field component, probably the two most important things are obviously the gravity meter, the machine that allows me to measure gravity. I wouldn't be able to do anything without that. And what's also very important is in this picture you can actually see the red thing in the background, that's the GPS. And this is a very special kind of GPS that can tell position to within millimeters sometimes. And that's very important because gravity measurements depend on how far away you are from stuff. So you have to know very precisely where you are. So MATLAB, the gravity meter itself, and the GPS are probably the three most important technologies.
And the product that you're able to come up with out of this are these gravity maps and charts, which we have a couple in our system here. Why don't you just tell us what we're seeing?
So this is a map of the data that I collected for my master's at Cerro Negro. So you can see I've labeled the different volcanoes. Cerro Negro is kind of that where all the black dots are. Each black dot is a point where I measured gravity. And the red areas are where there's high gravity, so that usually means lots of dense stuff. And the blue areas are where there's less gravity, so that usually means fluffy stuff. And so you can see, if you're looking at the black lines, which are the topography lines, you can see the outlines of the mountains. The mountains in this case are volcanoes, so that red stuff is most likely all the dense magma beneath the volcanoes. And the blue stuff on either side is the blue on the other side of these volcanoes are valleys, and these valleys are full of sand and volcanic ash, so lots of fluffy, not dense rocks, and so that's why it shows up as less gravity.
And then here's another view of it's the same volcano, but what are we looking at here?
So you just saw the map with all the pretty rainbow colors. So this is where the math comes in, the math and the science. You can take that map with all those pretty colors and you can do lots of calculations, and that can give you a 3D picture of what's underneath the ground. And that's what you're seeing here. So if you look over to the left where you see lots of those yellow and red blobs, in the middle of those yellow and red blobs there's a little red triangle, and that's Cerro Negro. That's marking the volcano I was interested in. And what the yellow and red blobs are is those are rocks that are denser. They have more stuff in them than the rocks around them. And because I know something about the geology of this area, I know that it's a volcanic area, I know that those rocks that are denser are most likely to be the solidified, the solid magma underneath the volcano. Actually, I know it's magma, but from this method I can't actually tell if it's liquid or solid. I can tell that it's there. Some of that might be liquid, some of that might be solid. But what's interesting about this is that you can see you've got lots of blobs that are all connected at depth. So it's showing me that that little volcano, Cerro Negro, is connected to its bigger neighbor, Las Pilas Oyo.
Very cool. We're going to move ahead here to a couple questions from Tara and Tikva. What's the deepest inside a volcano you've ever been? And what's the closest you've been to a volcano? And what do you like best about them?
What's the deepest inside a volcano I've never been? Well, I don't think I've ever actually tunneled inside a volcano. There is a volcano in Iceland where you can do that. That'd be really cool to do someday. I think the deepest I've ever been in a volcano has probably been in Hawaii, because the volcano, the Kilauea, has a very big caldera. The caldera is a sunken part on top of the volcano. And that, I think, is a kilometer deep. So I suppose I can say I've been a kilometer deep in a volcano, but I've never actually buried inside one. Sorry, what was the other question?
What's the closest you've ever been to a volcano?
The closest I've ever been, I've been on top of it, so distance of 0 centimeters.
Very close, very close.
Yes.
All right, we're going to jump now to a question from Fiona out in our live audience. What do you use to measure gravity, and how do you do it?
Okay, so this would be a good point to bring up that diagram of the gravity meter that I sent you. Yeah, okay. So this is what the guts of a gravity meter look like. That's the instrument that I use. It's called a gravity meter. And this kind of gravity meter is called a spring meter because it measures gravity by measuring how much this gravity is pulling on this spring. So there's the thing that's labeled zero length spring in the middle, and that's connected to a beam which has a mass on it. And so gravity, because gravity varies from place to place, how much gravity will pull down on that mass will vary from place to place. So when that mass is pulled down, the spring stretches. And you can measure how much that spring stretches, and then that gives you your measure of how much or how little gravity there is from place to place.
Awesome. So we're actually going to switch gears a little bit. We've been talking a lot about your current career and the kind of research that you've done, but now we're going to talk about how you got to where you are today. So we want to talk about your career path, and we have a question from Fiona again, and she asks, what caused you to choose to be a volcanologist?
Well, I actually didn't start out loving volcanoes from a really early age. I came to it when I was in college. I knew I was interested in geophysics, and it wasn't until I took a class in college about natural hazards, so things like volcanoes or earthquakes or landslides. And for this class, I had to do a research project, and in that research project, I had heard about this crazy thing where you could measure changes in gravity on volcanoes over time, and then that would give you a picture of where mass is moving beneath the volcano. And I thought that was the coolest thing ever. So that happened, and then around the same time, I got a job in one of the labs at my college that happened to be the volcanology lab. And what I was doing for this job was really menial. Basically, I had a whole bunch of rocks in a big sieve, and I was shaking them for hours because it was a way to figure out different sizes of rocks within this big rock sample. But just being around that part of volcanology, the volcanic rocks, the people who are involved with it, it kind of infected me, so I got volcano crazy.
So I'm not sure if you exactly answered this, but a question from Peiko wants to know, how old were you when you first became interested in volcanoes?
Well, I think I first really thoroughly got interested in volcanoes when I was in college. It's kind of ironic though, because I think from around the time I was 8 or so, we had this hilarious home video of me. As my family, we used to stop at this cinder cone volcano in New Mexico called Capulín Volcano. And we had this foam video of me. We decided to hike down into the cone of that volcano. It's dead. It's not going to erupt. But I was terrified. They have a video of me screaming and crying, is it going to erupt? It's going to erupt. And so the fact that I ended up working on volcanoes is just deliciously ironic and hilarious. But it wasn't really until college that I knew that that's what I wanted to do.
I wish you had given me that video to play during our program. That would have been awesome. Emily has our next question. Was there anyone that really made your dream of becoming a volcanologist possible, or did somebody help you along the way?
I think it really in large part was the professor who gave me the job in her lab. That was sort of my first real exposure to science and to volcanology. And I think that if she hadn't given me that job and hadn't kind of planted that seed in me, I might never have ended up doing that. Because I think before I was interested in plate tectonics, and it wasn't until her lab, and it was also her class, that the seed of volcanology got planted. So yeah, it was because of that professor, I think.
Another question from Emily. How long has it taken you to pursue your degree? So why don't you tell us what degree you have now, and how long did it take?
So I have a master's degree and a bachelor's degree. So bachelor's degree is the first step. That's the 4-year college. So that was 4 years for me. Sometimes it depends. Sometimes people take 4 or 5 years. And then I did a master's degree, and that was 2 years, 2 and a bit years. And I've currently applied to do a PhD, and that will be from 4 to 6 years. So it depends on how far you want to go. The base is a bachelor's, and that was 4 years. So far I've had 6 years of school.
Caleb and Hava have a couple of related questions here. If you could be something other than a volcanologist, what would you be, and what other occupations were or are you interested in?
Something other than a volcanologist. Well, I guess so where I'm working now is kind of my other potential career path. I'm currently working for a company that makes gravity meters, so that's more on the more thoroughly geophysics side. And so I could work for a company that does any sort of geophysical exploration, be it on volcanoes or in hydrothermal areas or in oil fields or in mining. So that's something I could do, and that is interesting to me because it involves data and math, and I love those things. If I wasn't in sciences, I kind of feel like I could have ended up being an event planner because that's something I love doing. I love organizing. I love making things happen. So all that stuff. So that would be my crazy veer off to something else career.
Something totally different. All right. Here's a question from Kyle that could also take us in a different direction. What is one of the biggest adventures that you have had?
Biggest adventures? I've been working on volcanoes, so there's kind of a lot to choose from. I think for me, the things that felt most like adventures were a lot of the things that I did in Hawaii. So there's that picture of me in Hawaii with the flight suit on, looking all excited. That was from the first time I went and flew in a helicopter. We flew in a helicopter out to this cone, and we were doing a GPS survey of it to measure how much it was inflating or deflating. And so that was an adventure because it was my first time in a helicopter. The helicopter had no doors. We're running around on an essentially active volcano through the smoke and the fog with gas masks on and on this really treacherous terrain. But at the same time, just knowing where I was and all the amazing things I was seeing, especially when the fog finally lifted, that was pretty awesome.
Very cool. I have also flown in a helicopter over Hawaiian volcanoes. And second big piece of advice for all of our audience out there today, highly recommend doing that. It's awesome. We're going to move along here. We've asked you a lot of questions so far, Patricia, and there's more to come. But right now, we're going to ask our audience some poll questions that you came up with about you and your career. So let's jump to the first one now. What kind of safety equipment has Patricia never worn when doing field work on a volcano? Has she never worn A, a gas mask, B, gloves, or C, a heat suit? So I think you've talked about a couple of these, at least one of these during the program. So if folks have been listening carefully, they probably can rule out at least one of these, knowing that you have worn them. We have answers coming in live. I'm able to see these percentages, and I can let you know, Patricia, right now 38% think you've never worn gloves when working on a volcano. 67% think you've never worn a heat suit, and actually that's up to 70% right now. Heat suit is in the lead. Patricia, why don't you tell us what is the right answer here?
So clearly you've read my profile because it is C, heat suit. That's one of the things I get asked frequently is, oh, do you wear that awesome silver suit when you go to volcanoes? And the answer is actually no, because most of the time I'm not working anywhere near heat. And second of all, you have to be next to a really, really big amount of lava to need a heat suit. When I've been next to lava, the most that's been required is to wear long sleeves and long pants of natural fibers, cotton, and gloves. Gloves are important even when you're not next to heat because volcanic rocks are sharp, and if you fall on them and you're not wearing gloves, you're really going to scratch up your hands. So gloves and a gas mask, definitely. Heat suit, no.
And this wasn't one of the options, but we're looking at your boots from one of your trips. Why don't you tell us this story real quickly?
Yeah, so this is the saga of the boots. So my advisor told me when I was working on Cerro Negro, you need to have leather-sided boots because the rocks are sharp and they will cut up my boots. I didn't believe him, and within 2 hours of being out on this sharp, spiny lava, I had 2 huge gases in my left boot. So then the next day I had to go out in Leon, Nicaragua and try and find working boots that fit a female, which was somewhat difficult. And then the next day in field work, we got literally the farthest point away from our vehicle, at which point both the soles of my shoes fell off. So I had to hold them on somehow with bungee cord and shoelaces. And so the next day I lost another half day of field work because we had to go find someone to sew the soles back on. So that was a fun day.
It's the challenges of working on a volcano. Let's go to our next poll question here. Which of the following volcanoes has Patricia not visited? Has she not visited A, Pinatubo, B, Kilauea, or C, Sakurajima? How am I doing on pronunciation of all of these, Patricia? Pretty good.
Good.
Not too bad. Why don't you remind us just kind of where in the world each of these is as our audience enters their guesses. Where is Pinatubo?
So Pinatubo is in the Philippines. It erupted in the 90s, I believe, was a fairly large eruption. Kilauea is in Hawaii. It's currently erupting, but lava. And Sakurajima is in Japan, and it's currently erupting explosively.
All right, and we have talked about at least a couple of these. Let's see how close our audience was paying attention. Right now, 44% think you have never been to Pinatubo, and 56% think you have never been to Sakurajima. Nobody thinks you've never been to Kilauea, so they've clearly been listening on that front.
That's good.
But why don't you tell us the right answer? Which of these have you never visited?
So I've never visited Pinatubo in the Philippines, although I would love to because it's a very iconic volcano in volcanology because of its huge eruption in the 90s and also because a lot of the hazard planning and volcanology that came out of that eruption. But I have been to, obviously, Kilauea. I've been hearing a lot about Hawaii. And I did get to go to Sakurajima last summer when I went to a conference in Japan that was in a city that was right across the bay. So I got to go to Sakurajima along with hundreds of other volcanologists who just swamped the viewing area. We're all so excited and ecstatic and taking 700 pictures a minute. And yeah, it was pretty exhilarating.
Pretty cool. Our third poll question today, how old was Patricia when she first knew she wanted to study earth sciences? Was she A, 5, B, 21, or C, 18? And I think we probably just talked about this moments ago. So we're just going to give our audience a very short window of time to enter their answer here. We've got a mix of answers already coming in. In the lead at the moment is 18 with 57%. We've got a smattering of votes for 5 and 21. But it looks like our audience was listening pretty closely, I think. So why don't you tell us the right answer, Patricia? How old were you when you first knew you wanted to study earth sciences?
So I realized this is kind of a trick question because I had a question about when I knew I wanted to study volcanology, but I knew before that I wanted to study earth sciences. I took a course in high school that was interfacing computers with real life objects, and during that class I got to do a shadow at actually the geophysics company where I'm working now, as it turns out, and just something lit off in my brain. I thought, this geophysics stuff is awesome. So I knew going into college that I wanted to do geophysics, but it wasn't until I got that job in the volcanology lab that I got the volcanology bug.
You tricked me as well. I think I was probably sending the wrong vibes to our audience, trying to point them in the right direction. So it's time to move on now. We're actually going to talk about, ask you a couple of questions about your personal life, things that you're doing when you're not studying volcanoes or working in your current job. Emily asks, what do you enjoy doing in your free time? And Jonathan wants to know pretty much the same thing. What do you do when you have free time or a vacation from your job?
So my main thing that I love doing is I love to dance. The kind of dancing I like doing social dancing. So that's things like conjure dancing or salsa dancing or ballroom. And that just makes, I love the social interaction and I love the music and I love dancing, and I'm basically a dancing fool. And then in terms of having vacations, I haven't really had a proper vacation in a while, but I'm hoping to, this time probably next year, I'm hoping to go to Europe because during my master's degree, I have a lot of friends who are from Europe that were at my school, and some of them have trickled back to Europe. So I really want to go visit them because there's a possibility of seeing Europe with free couches, which is always a good thing.
Very nice. You mentioned dancing, and Sarah and Emma read your profile, and they noticed that you do highland dancing. They want to know, what is highland dancing? So
highland dancing is traditional Scottish dancing. It looks like a combination of ballet and aerobics. So it's usually done, the dancers wear kilts, we dance to bagpipes, sometimes we dance over swords. If you see people with their arms like this or like this, and they're wearing kilts, they're Highland dancers. So it's a lot of jumping. Usually actually, yes, this is a good example.
There you go.
So I'm doing
Sometimes you can Highland dance on a volcano.
Yes, so I'm doing a move there called a high cut, which appears in a lot of Scottish Highland dances on Cerro Negro. But yeah, bagpipes, and we dance over swords sometimes, and kilts. And if you go to like a Scottish-Irish festival, you'll almost certainly see it there.
Yet another thing, I wish you had some video that you could have shared with us. That would have been awesome to watch you dancing with swords. We're going to ask a completely different kind of question now. Haley wants to know, if you could go back in time, what would you tell yourself?
Probably variations on a theme of chill. It will work out. Yeah, I also been thinking a lot lately that I wish I could have told myself that, you know, even if something is hard for you now, it doesn't mean you won't get it eventually. Because I'm finding in my current job now, especially with a lot of the math I'm using, it's a lot of math that when I saw it in high school or in college, I didn't maybe really get it the first time, or I kind of got it just enough to pass, and I didn't really feel confident in it. And what I've realized as I've gone on is that sometimes it takes seeing something 2 or 3 times before you really understand how it works. And I wish I could have told myself that just because you don't understand something the first time, or you think it's really hard, or you spent all of your AP physics class crying and screaming at the homework assignments, that doesn't mean you can't do it. It just means it's hard. But if you come back to it enough, then eventually, yes, you can get it.
Great piece of advice. We're going to move along again. Our next segment, we're going to talk about the future. And this is both your future, Patricia, but also the future of our audience out there, some of whom are inspired to be volcanologists themselves now, clearly, from the questions that we're getting. So our first question here is from Emily, and she asks, in your company or field, what is your goal? Like, do you want to be a head researcher or a teacher, or what do you want to do?
Oh, see, that's something I'm still trying to think about myself. I sort of see myself in maybe 2 possible choices. One possible choice is if I work in industry, kind of like what I'm doing now. It would be awesome to be sort of a senior geophysicist in the company, or maybe even have my own company, to be able to sort of decide what projects we do and what research we do. And then the other career track that I'm very interested in is I would love to be a professor, because I love doing research. I love poking at, well, this thing's interesting. What happens if I do this? Can I figure out this thing? And then I also really love teaching, and I love spreading the excitement of geophysics to other people. So which one I end up in, I think, will be dependent on what sort of opens up for me in the future. But I think I could be happy either way.
Mackenzie has a couple questions about their future. Wants to know, what are some first steps in becoming a volcanologist, and what are some suggested majors if you wanted to become a volcanologist? What's the path?
So the path to volcanology is almost definitely earth sciences. So a lot of schools have an earth sciences or a geology program. Some schools will have separate geology and geophysics programs, but a background in either can lead you to volcanology, because volcanology has different parts in it. Some people in volcanology focus more on geology, which is looking more at, you know, what's the structure of the rocks or what the rocks are made of, where geophysics is looking more at, can we see beneath the earth? How is the volcano moving? How is it deforming? So going for something that's related to earth sciences, that is a surefire way to get yourself on the path to volcanology.
And once you've done so, Emily wants to know, are there many jobs available for people who want to be a volcanologist? What happens after all of that education?
Right. So that's sort of a mixed bag. If you're going to be in purely volcanology, which would mean either working for the government like the USGS or a state geological survey, or working for, say, a university as a professor, as a researcher, that can be a little more difficult just because there's a lot of people who want to be in the positions and unfortunately not very many positions. However, I do know that a lot of the skills that you learn doing volcanology are applicable to other places. I mean, that's what I'm doing right now. I learned how to do gravity and how to do geophysics during volcanology, and now I've been able to apply those to a job in a more straight geophysics, almost engineering company. And I also know of at least one grad student that I knew when I was an undergrad who she did research on bubbles moving in magma, and that actually ended up being applicable to the oil industry. So, and then I also know of, you can also work in the geothermal industry, so it may not be a straight path to study volcanology and a volcanologist, but you can definitely do things with the degree. You just might have to be a little more creative.
Makes sense. We've got a question next from Madison. What is the hardest and biggest challenge that you have faced so far?
Hardest and biggest challenge. I think I struggled a lot with the fieldwork because when I'm in the field, I can keep up. I don't faint, but it's not really for me the thing that makes me excited. And it's also because I have short legs and my field partner had really long legs. It was really, really frustrating to me that how much science I could do was limited by how strong or how fast I was physically. And that was really mentally frustrating to me. And that was kind of getting over that aversion and frustration with field work was kind of difficult. And then also just when I was in the master's, it's even though it's only a 2-year program, it's this big, overwhelming thing that you have to do, and it just hovers over your head and you can't escape it. And learning to deal with that was pretty hard, but I did figure it out. I learned some really great ways of coping with big projects from doing that. So yeah, I faced my fears and I overcame them, and it was a good story in the end.
So speaking of big projects, Haley's wondering, what's the next big thing you're doing?
So the next big thing I'm hopefully doing, waiting to hear back, is I've applied to the Colorado School of Mines to do a PhD in geophysics. So I won't hear back about that until April or May. So, but if that works out, that will be the next big thing I'm doing is getting my PhD and diving into more of the nitty-gritty of geophysics and gravity and all of these things that make me really excited.
Awesome. Well, it's great to hear that, and we wish you luck, and hope everything works out the way you want it to with
Thanks.
the next step in your career. Unfortunately, we've run out of time. We still have tons of questions that our audience has asked, but we have no more time to ask them of you. But it's been fascinating to hear your answers to what you were able to answer today and learn about your career. And thanks for sharing your advice and your enthusiasm with us all. It's really fun.
Yeah, you're welcome. I had a great time.
All right. Coming up next for Jason, our next STEM role model is oceanographer Mona Beal. Mona is the research coordinator and climate change specialist for Texas Sea Grant's research program. She's originally from a small landlocked town in India, and she had never seen the ocean before traveling to the U.S. to pursue her PhD in oceanography. She overcame that and many other challenges to land a job that she feels is full of excitement and adventure. If you want to hear more about Mona's STEM career and career path, be sure to join us next Thursday, April 3rd at 1:30 p.m. Eastern, or second show at 6:30 p.m. Eastern, to learn more and ask Mona your questions about being an oceanographer. Once again, that's all the time we have for today. My name is Patrick Shea, and for Jason Live, thanks for joining us. We'll see you next time. Take care.